Looking at the 3 warm-up questions, we can take the first one and simply see this as divide both by 4/4, which would be 3/4. I can divide this number by 4 and this number by 4. It's equivalent to 3/4 because I'm dividing out the same factor. 12/16 and 3/4 are equivalent, or equivalent fractions. We can also see in this one the same idea. If you didn't see the greatest factor, we can pull out any factor. I see 8 quickly. When I divide by 8, I'll get 4/6 and think, oh, there's another factor there. I could have divided, instead of by 8, by 16, or I could divide by 2 another time. This gives me 2/3. 32/48 is equivalent to both 4/6 and 2/3. To get there more directly, I could have divided by 16. Notice that dividing by 16 is the same as dividing by 8 and then dividing by 2, because 8 times 2 is 16. I'm pulling all of the factors out at one time. To do that, you want to pull out the greatest common factor. The greatest common factor of 32 and 48 is 16. That's the one that'll get you to the lowest terms the fastest. If you don't see it right away, you can do what I've done and do it in 2 chunks. Both work and you get the same answer in both cases. You want to make sure you go to the least lowest terms. You want to use the biggest number that you can divide, so the GCF, or the greatest common factor, works best. In the next problem, 288/360, I could divide by 2, and then I could try 2 again, and I could continue like that. But these numbers are pretty large, and I don't see a big factor that's common right away. So to do this problem, I prime factored these. So looking at 288, I ended up with 2 to the 5th times 3 to the 2nd. And doing 360, I got 2 to the 3rd times 3 to the 2nd times 5. I can then take this and put it back into a fraction. 288 was the numerator, 2 to the 5th times 3 to the 2nd. And my denominator is 2 to the 3rd times 3 to the 2nd times 5. I can then pull out common factors, or things that they both have. In this case, they both have a 3 to the 2nd. I can divide out that common factor, because 3 to the 2nd over 3 to the 2nd is like a 9 being a factor of both of those numbers. I'm essentially doing what I did up here, dividing by 8, but in this case I'd be dividing by 9. When I divide by 9, that 9 goes away, or cancels out, or becomes one whole. 3 to the 2nd over 3 to the 2nd is equivalent to 1. I can do the same thing with the 2 to the 3rd and the 2 to the 5th. What I'm really doing is taking 3 2's away here from the 5 2's that were up top. To divide out this form of 1, I divide 2 to the 3rd in the denominator, and that disappears. When I divide 2 to the 3rd out in the numerator, I'm left with 2 to the 2nd. My answer here would be 2 to the 2nd over 5, which is also 4/5. To see this another way, I could write the prime factorization out like 2 times 2 times 2 times 2 times 2. That's 2 to the 5th times 3 to the 2nd. That's my numerator. Oops, 3 to the 2nd, 2 3's. My denominator would be 2 to the 3rd times 3 to the 2nd times 5. 3 to the 2nd. In this case, I can divide out what they have in common. They both have 2 to the 3rd. That's a form of 1. They both have 2 3's. This is another form of 1. Just like I canceled out the 3 to the 2nd here, I can cancel out the 3 to the 2nd here. Same thing with 2 to the 3rd was taken out of the top and the bottom. What I'm left with is 2 to the 2nd over 5, or 4/5. The 2 other warm-up problems I'll do on another video that you can look at in a minute.